Hello everyone. Today I'm going to introduce you more disappointing paper on nature.
Mysteries of the universe.
So as you might know, Nature is one of the most prestigious journal in astronomy. So most important paper or most surprising paper in astronomy will appear in Nature. And as usual, I was checking new papers appeared on Nature Astronomy in this case. Nature Astronomy is astronomy version of Nature. And I came across this paper. Let's look at the title. It says Radio Technosignature. Technosignature means alien signature towards Proxima Centauri. Proxima Centauri is the closest star from the Sun, resulting in a signal of interest. That sounds very interesting, no? It is something like an alien signature was found from Proxima Centauri. I got very interested in this paper and I kept reading, going on to the abstract, and in the third line of the abstract they say, we report on the detection of a narrowband signal of interest at 982 MHz. They detected a signal of interest in this frequency. That's exciting. And then I continued to the fifth line. It says this signal has characteristics broadly consistent with hypothesized technosignatures. The characteristics of the signal is consistent with alien origin. It's more exciting, it's very exciting, right? And they keep going. Signal is one of the most compelling candidates to date. One of the most compelling alien signatures to date. Oh, this may be a great paper. So from the title to the fifth line of abstract, it's all very exciting. And then I kept reading, and on the sixth line in the blue, analysis of BLC1, which we ultimately attribute to being an unusual but locally generated form of interference. Huh? Locally generated form of interference means that means something from the Earth. Form of interference, that's noise. So in this sixth line, they say it's a noise from the Earth. How can it be that way? I was so excited until the fifth line of abstract, and so a little bit disappointed to read sixth line. Okay, let's see in more detail what happened, what's reported in this paper. So this paper is from this Breakthrough Listen project. This is a US $100 million project, and then they're using many telescopes around the world to search for alien signatures. And then this Australian Parkes 64-meter telescope is one of the telescopes they use, and then this time signal was detected was this 64-meter Australian Parkes telescope. A signal was detected when the Parkes telescope was observing Proxima Centauri. Proxima Centauri is the closest star from the Sun at 4.2 light years. But what's interesting about this Proxima Centauri is it has two planets, Proxima Centauri B and then C. Now, one of the planets, Proxima Centauri B, is a habitable planet like the Earth. So it might have water, liquid water, it might have atmosphere. So people are discussing there might be an alien life on Proxima B. So it is more exciting to get alien-like radio signal from Proxima Centauri, where a habitable planet is. And then this is a signal detected with the Parkes 64-meter telescope in Australia. Signal was actually found in 2019 by an undergrad student. And there are several exciting points about this signal. First, the signal, this yellow part, is very narrow band frequency. This is consistent to be an artificial origin because signal from the nature is more broad. It's not just at single frequency, but signal from black hole or pulsars or stellar flare or the sun, it's more broad in frequency, and sometimes it gets bright, sometimes it's faint. It's natural phenomena is like that. But man-made signal, artificial signal, is sometimes at a single frequency. For example, our cell phone frequency is at a fixed frequency, right? Our Wi-Fi frequency is also at fixed frequency, 5 GHz or 2.5 GHz, it's fixed frequency. Man-made signals are like that. And then this signal looks exactly like that. It's a very narrow frequency range. So it doesn't look like a natural phenomenon. The second point is a little bit worrisome. The signal is at 982 megahertz. In Australia, this 982 megahertz is a frequency for airplane communications. So that's a little bit worrisome, right? This may be a signal from an airplane, but at the time of observation, there was no airplane within 1,000 kilometers from the telescope. So it cannot be a signal from airplane. And also the signal lasted 5 hours. So no airplane is going to stay at one place for 5 hours, right? If airplane's flying, after 5 hours, it's probably long gone to somewhere else. So it's not very likely to be an airplane signal. And then another interesting point is you can see the frequency of the signal is shifting, right? As time goes by, the frequency is shifting. This is Doppler shift, and it happens because the source of the signal is moving relative to the Earth. Very interestingly, the amount of the Doppler shift is consistent to the motion of the planet B. So it may be, the planet B is going around Proxima Centauri, right? So it's consistent with this motion. So this signal may be from Proxima Centauri B. That's how people got all excited. However, this recent paper reports, after more careful analysis, 60 similar signals like this one were found. And then some of the signals were detected when telescope was not looking at Proxima Centauri. So the conclusion of the paper is this is probably radio interference from unknown sources, because they don't know the sources yet, but if the signal is detected when telescope is not pointing to Proxima Centauri, then the signal is probably not from Proxima Centauri. So unfortunately, it was a radio interference. Okay, this time result was a little bit disappointing, but this breakthrough recent project, this is a 10-year project, so it continues. And then now the team knows how to filter out those interference signals much better now. So I look forward to their detections of real alien signals in the near future. Okay, I stop here. See you next time. Bye-bye.